Good afternoon, everyone. Thank you for joining today's Residio webinar session. We are excited to be providing an overview of our ventilation portfolio today. My name is Jamie Quanrud, and I'm part of the Residio sales training team. And on behalf of all of us, I'd like to welcome you to our training session today. And before we get started with our technical overview, I'm going to cover just a few administrative items. Make sure you join us each month as we provide you with 2 opportunities to learn about our Residio products. And going forward, we are offering these webinars for you on a regular basis. So please be sure to visit residio.com/webinars for more information on these upcoming sessions. We will be posting our June and July schedule shortly, so be sure to check back for those details on those upcoming sessions. Additionally, we will be sending out an email in just a few weeks with the details on our upcoming customer webinar sessions as well. You can also find recorded sessions on this same website underneath that webinar recordings tab if you are unable to attend the live session and want to review some of the information that we covered previously. For our contractors who are joining us for today's live session and you are interested in earning 1 NATE continuing education credit, there are just a few things to note. If you provided your NATE ID on your registration form, we will submit those details to NATE for your attendance of today's live session, and we won't need any additional information from you at this time. If you did not provide us with your NATE ID on that registration form for today's webinar and you'd like to receive credit for attending our live session, we do ask that you email your first name, your last name, your NATE ID, and the date of the session that you attended to homes.university@residio.com within 1 week from today. This information is submitted to NATE 1 week following the close of each live session, and any requests that are sent outside of 1 week from any live training cannot be processed. As a reminder, we can only process requests for NATE credits when you attend the live webinar sessions, and we are unable to process requests for watching any of the recorded versions of our training sessions. If you'd like more information about the NATE program, please visit their website at www.natex.org. And then there's just one quick note before we begin our technical overview today. All of our attendees are muted. However, if at any point during the technical overview you'd like to ask a question, please go ahead and use that Q&A feature that is found in your Zoom webinar controls. And we are reserving the last few moments of our time together today to answer your questions. So as we progress through the technical training, please be sure to ask those questions in that Q&A feature so that we can address it at the end of today's session. We'd love hearing from all of you and any questions that you may have on ventilation or our ventilation products. So now we're going to turn things over in the presentation to Chuck Rose, who is part of our Residio sales team in the Southeast. Chuck is well versed in all things indoor air quality, and we're excited that he's going to share his knowledge of our ventilation portfolio today with us, and also share the importance of the role of ventilation inside the home. So Chuck, we're going to turn things over to you. Thanks for being with us today.
Absolutely, Jamie, and thank you for inviting me. And as Jamie said, my name is Chuck Rose. I am the territory manager for Eastern Tennessee and Western North Carolina, as well as Northwestern South Carolina. And I am particularly fond of ventilation, so I'm pretty excited that I get to present to you guys today. Just a quick thing here. We're going to go over some pillars of IAQ. We're going to talk about humidity control and dehumidification as it relates to ventilation. And then we'll do some common questions. And then, of course, we'll have some time for Q&A at the end. I always like to start off by saying Residio is not a one-trick pony, if you will. We actually are a very well-diversified company in terms of our offerings. Many people think of us as just the Honeywell home thermostats, but we also are very much involved in the IAQ world. We have everything that's necessary to control your indoor air quality. Ventilation is one of the reasons why I like ventilation, is because it is sort of like the redheaded stepchild of the HVAC industry. We tend to think that we're the HAC industry, if you will, and sometimes the V gets left out. So it's really fun for me to teach on this and to kind of introduce this sometimes to people, but also refresh some people on what ventilation does and why it's important and how to do it right. So anyone who's been in the industry for any amount of time probably has heard the saying that houses need to breathe. And I always chuckle when I hear that phrase. The truth actually is that people breathe, but houses really don't need to breathe as much as we tend to think. So when we talk about ventilation, what we really want to do, the ultimate goal in a perfect world, if we could build a perfect home, we would actually want to seal a home up, just kind of like the picture that you see here. We'd want to seal it up airtight, vacuum sealed, so that nothing was getting in and out, and then we could control the ventilation, and so we could decide what's coming in and out. Because a popular saying that I've heard a lot as I was being trained in building performance was seal it tight and then ventilate right. So we want to be in control of what comes in and then therefore what goes out of our homes. There's a lot of indoor pollution that can be a factor inside the home with IAQ, but there's also a lot of stuff that comes out from outside. Our houses tend to act like big filters. And then of course, anything that we bring inside that has nasty stuff in it, pressed wood and formaldehyde is common, but also anything like candles and deodorizing sprays, and those kind of point us to the fact that not all indoor air pollutants are bad. They might be things that we want to watch out for, but I mean, nobody's going to tell you that you can't burn a candle in your house. But we have to recognize that all of those things, they do release things into the air. And then of course there's things that we may not be so much in control of, like radon, because we can't really predict radon. And then of course carbon monoxide and carbon dioxide are two gases that are produced by things in the home. Carbon monoxide, of course, by combustion appliances, and then carbon dioxide is something that we as people produce. We breathe that out as our bodies exchange it for air. So lots of stuff going on inside the house, and so it's important to kind of understand all of those things that are there. And we certainly have products and we have technology to help us mitigate all of these issues. But the best strategy anyone would tell you is that if we can dilute these things down to a level where they are not significant, then that is one of the best strategies. And so ventilation is where that comes in, because with ventilation we're able to actually dilute the concentration of everything that's in the house with fresh air. So obviously we spend quite a lot of times in our homes. 90% of our time on average is spent in the home, and so we want to make sure that we have good air. Obviously indoor air pollution is a problem if we don't ventilate, but we can also have things like excessive moisture. Depending on the climate that you're in, you can have vulnerability to gases, like I said before. Mold and mildew can become a problem when you don't control for ventilation or for humidity in the air. So lots of things can happen if we're not watching out. And everybody kind of knows that. Most of us have experienced that in some way or another. But the thing about outdoor air is that there's a whole lot of it. And when we're talking about the dilution aspect of ventilation, it's important to think about, what is in the air and what is the concentration of that. And so to this last point down here, even if you're in these highly industrial congested areas, the outdoor air, certainly important to know what's in it, but outdoor air is usually much less concentrated in terms of the harmful pollutants that can be in it. And so bringing that inside usually is going to be a negative or a net positive. Now, if your neighbor is burning leaves, or I don't know if any of y'all remember a couple of years ago in the Southeast, we had the fires in the Tennessee and North Carolina mountains, and all the way down in Atlanta. The air was just almost impossible to breathe, and I mean, and that's a couple hundred miles away. So during those days, we were not running our air. We were not running our ventilation because we did not want to bring that inside. So there are times when we want to, be in control, but again, that is the key word there, is we want to control that ventilation. We do quite a lot of before and after type stuff. And so I just, some of these graphs can be a little, they can be eyesores and stuff. And of course, if you've been in the industry for any amount of time, that there are so many variables. So everything, you want to make sure that you look at these graphs and you take them for what they are, right? These are actually reports that we pull from our air cycle monitors, and we'll talk about what that is later towards the end. But when it comes to things like carbon dioxide, before and after introducing ventilation into a home, you can see that in the before, carbon dioxide is very, very volatile, but it's also way above the control point, right? This green line here is what we want to control for. We want to stay below that. And then down here, you see that the averages are very high. And then you see down here on the after introducing ventilation, we're able to bring that down and actually keep it below the line at all times. There's still going to be fluctuation, and usually with carbon dioxide, that has to do with what's going on inside the house, like if you're cooking or if there's a lot of people there or something like that. And then again, with particulates, you can see here before and after graphs. Again, it's all about concentration. So if we can dilute those, then we can make our indoor air quality much better. And of course, I think this is really a cool one right here. And this is, if you look at this is what we call odors and smells with homeowners, but you may have heard of it as VOCs or TVOCs. These are organic compounds that are in the air. And these are usually things from candles or, cooking pasta or burning your bacon or something like that. And you can see again here around, I think that it's difficult to see, but I think that's 6 p.m. You see this spike here. These people are cooking, and then they're probably, having some kind of a meal or something like that. And then you go down overnight, and then in the morning you see, like it comes back up. And so you get these spikes, but with ventilation, we're able to actually keep those below and even level out those spikes. So it's really interesting to see what we can do with ventilation. There's lots of different ways, or there's really 3 primary ways to ventilate a home. Every home in the US that's been built in the recent years, I mean, really should pretty much have a bath fan. And oftentimes bath fans are looked at by people as being there to remove odors, but really they're actually there to remove moisture. And if you think about it, that can be a pretty scary thing, because if we go back to what I said before, which is that we want to be in control of what comes in and out of our homes. If you look over here to the side, to the right-hand side where we have these graphics, If you see kind of the house up at the top, it's kind of squeezed, and what we have there is a negative pressure inside. And so what we're doing is we're just basically begging the air to come inside from outside. The problem is that, you know, we would like to think that it's coming from the window over the garden, right, where the air is fresh and everything's great. But more than likely, it's probably coming from our attic or our crawl space or our basement, because usually those are easier pathways. So with exhaust only ventilation, we have very little control over where the air that is coming into our home is coming from. And of course, if we do extreme negative ventilation, then we can have problems with our combustion appliances, backdrafting, which can be a very, very dangerous situation. So it's not very often that you see a bath fan causing a backdraft situation, but it's possible. So, you know, anytime you have an exhaust only situation, you just need to be aware of those dangers. But in my experience, especially in new construction, bath fans tend to be rated for a certain amount of CFN, and they usually only remove a fraction of that by the time everything is installed. So, you know, it's just some things to keep in mind. The opposite of that would be, of course, supply only ventilation. You know, there's two ways to do this. You can do a passive system, which I've seen a lot of, and that would be simply running an intake from somewhere on the outside of the house through a duct into the return of the system with no damper or anything like that. And that would be a supply only ventilation system. But the problem with that is that you, again, have no control over it. You have no control over it. So basically, anytime that the equipment is running, you're bringing in as much fresh air as can fit through that duct. And then, of course, a step up from that would be to introduce some kind of a damper into that system, and that would allow you to have control over that. So obviously, that's a better solution. And then there's various levels of control that you can introduce depending on the products. If you do supply only ventilation, in my opinion, supply only ventilation is better than exhaust only ventilation, because again, you don't have so much control about where the air is moving, but you're moving air from outside to the inside through a controlled system, and the air that is exhausting is what is uncontrolled. So, and we don't care so much about that. But the problem there is that you introduce a positive pressure into the home. And if you do that, if your duct system is not sealed extremely tight, then you can start to lose a lot of your air through leakage in your duct system. And then, of course, you're also losing that conditioned air through leaks and cracks throughout your home. Balanced ventilation, of course, is the gold standard, right? I mean, because we want to be in control of everything. It is more expensive, but a balanced ventilation system can be very complicated, and it can be very simple. Usually a balanced system is done with an ERV or an HRV. If you're in a northern climate where humidity is not typically that big of an issue, but heat loss is, then an HRV is a great product. But if you were to use an HRV in a southern climate like mine, then you would have major problems. And so we have what's called an ERV, which is an energy recovery ventilator. And that is going to not only exchange heat, but the humidity as well. There are standards for ventilation. ASHRAE actually introduced a new standard, 62.2, in 2016. There's been quite a bit of controversy over their standard, but you know, they are the authority in the industry, and so we would do well to listen to what they say. But one thing that I think is important is that we understand the standards and we abide by them. But we also need to understand that sometimes for specific instances, we need to tweak what we actually end up with. right? So if you look here, the at 62.2 standard, there's two ways to do it. You can use the chart over here, which is kind of a simpler formula, or simpler than using a formula. You can basically look at the square footage of the home and the number of bedrooms, and you can get your number of CFM per hour. And then you can run your system based on that. Or you can use your formula to get a more precise number. And this is basically the Q total would be the amount of fresh air you need. You take the area of the square of the square footage of heated and cooled conditioned space, multiply it by 0.03, and then you add 7.5, and then you multiply that by the number of bedrooms plus 1. Essentially, that's going to give you something close to these numbers over here. And if you use a design software, they probably have this built in to their system. So if you're using a design software to do a load calculation or something, they're probably going to use this formula to calculate it for you. Some of the products that we have, some really neat products that we have. We actually have products that fall into all three categories, because we do like to have options for every situation, because there tend to be people who need each situation to be accommodated. So the exhaust only ventilation, this is not a widely known product, but it's a fantastic product. If you're gonna do exhaust only ventilation, this right here is a high voltage direct replacement for any bath fan. And so you actually would just take the bath fan switch out of the wall, you would replace it with this controller here, and it has various modes of operation, but the coolest one is that you can actually program that formula into this controller, and it will run your bath fan to meet the ASHRAE standard for exhaust ventilation. So it's a fantastic little product. It also has a timer, a countdown timer. So, if you you want to set that, you basically just push the button to turn it on, and then it'll run for 15, 20, 60 minutes, however much you want. So for example, if you were to take a shower and you had a 15-minute timer, the shower, in 10 minutes, then it's going to run an extra 5 minutes after you leave, but then it's going to shut off. It's not running all day long. So it's a really cool controller. If we wanted to do supply ventilation, we do have supply dampers that are normally closed. These are what we use. These red face dampers are what we use on those systems. And then we have various types of controllers. What you see pictured here is our 8150 controller. We'll talk a little bit more about that in a minute, but this is kind of the, if you have to do it without a thermostat, but most of our smarter thermostats that can do IAQ actually will have that control feature in it. So highly recommend that. And then of course our balance systems. This is a picture of, it's impossible to tell from the outside, but it's either an ERV or an HRV. And this is our small, our mid-level models, but just to kind of look at some of the models there. We have the EARDs, which are our dampers. These are more simple. The HRVs are, like I said, these are heat recovery. So just one thing to note, I don't know how many out there are in northern climates or versus southern climates, but if you're in a southern climate or anywhere where humidity is an issue, the HRV is not for you. So when you see the difference in the price tag between an ERV and an HRV, don't think that you just want to save a little money and walk away. An HRV, I've seen them, if they're not installed properly, they can be bad news. So anywhere where you're looking at any kind of humidity issues, you want to use an ERV. We have 3 different sizes: the 70, the 150, and the 200 CFM system. They're balanced. They run with independent fans, both on the intake and the exhaust. And then, so you can actually, balance your system. The ventilation solution for exhaust only, like I said, just wanted to give you a little bit more info here. The digital bath fan control, this thing has several different modes. Like I said, that it can meet ASHRAE 62.2 if you program the info in it. You can do a customized cycle mode, where you can actually, it's almost like a programmable thermostat. You can tell it when to come on, when to go off. You can have the daily on and off mode, manual, and then of course the countdown timer. For supply ventilation, this is actually the one where I hang out most of the time. And the reason for that is that, well, there's lots of reasons, but in my climate, we have lots of humidity. And so I really, really like being able to, bring fresh air in through one of our dehumidifiers, which is what we do with the DR90 or the 120. We can actually use those things to control both humidity and ventilation at the same time. But if that's not quite in the budget, then we also have the 8150s, which are also a very great solution. You can actually just program the relevant information into the controller and it'll do all the calculation for you. And these, even though dehumidifiers tend to be expensive, these tend to be actually a more economical solution than a balanced system. With the 8150, we have the Y packs, which anyone who, if you're not familiar with our labeling, any kind of part number of ours that starts with a Y means that that's actually a package deal. So we call them our Y packs. So the Y8150 is going to be a package that has a transformer, it's got the damper, and then the controller all in one box. And then for this guy, you're just going to basically go in here, you're going to tell it with these dials, you're going to say, okay, I have 4 bedrooms, I have this many square feet, and the one that trips people up a little bit sometimes, and this is important here, is that this airflow, this is not the desired airflow. This is actually your measured incoming air from your fresh air supply. So whatever duct you're running from the outside to your system, you will have to measure how much air is coming in through that. And then you tell the controller how much air is actually coming in through that. It's it's a pretty easy system to set up. It's very customizable, and again, it's a very economical solution. We also have another Y pack that has a damper in it, and this is the YTH8321WF. The 1036 or the 1044, that just depends on what size damper you want. But this is a box that comes with a Wi-Fi 8000 thermostat and the damper. And the reason that we would pack that together is that whereas the other one is an analog control, with the 8000 thermostat paired with this damper, you actually, first of all, it's a lot easier to set up because you just need 2 wires from the thermostat to the damper. And the thermostat will control everything, including the heating and cooling, right? So and then the thermostat's able to utilize more information, such as the outdoor temperature and the outdoor humidity, to introduce some higher level of control. And we call those lockouts. So with the 8000 thermostat and many of our other IAQ thermostats, we can control for high or low outdoor temperature, high outdoor dew point, and then we can also control for a sleep schedule. The reason that we go dew point instead of relative humidity is because it's a much more accurate predictor of introducing humidity problems through ventilation than relative humidity. So this example here is just kind of showing you, if you're doing supply only ventilation, what a calculation might look like. So if you had a 2,000 square foot home with 2 bedrooms, ASHRAE 62.2 would require 60 CFM of continuous fresh air. That's a whole lot of fresh air, but according to that calculation, that's what you'd need. So with a 6-inch duct, assuming that it's giving you 60 CFM, which is it's an average. You would have to have that duct running 100% of the time. And then of course, if you went up to an 8-inch duct, which is going to deliver twice that much airflow, then you would only need it to be running 50% of the time. Our ventilation systems are going to introduce into their intelligence their knowledge of when the system's blower is running. So it's going to try to optimize the ventilation cycle with the fan run cycle, whether you're in heating mode or cooling mode. So it's going to try to engage your system fan as little as possible during times when there's no heat or cool call. If the heat and cool doesn't run enough, then of course it will engage the system fan independently, but usually it tries to optimize that. A great way to mitigate the problem of bringing in fresh air and humidity at the same time, which is something that we deal with all the time here in the Southeast, is to bring in your ventilation through a dehumidifier. I like to talk about this as you're essentially, when you do this, you're kind of getting double for your money. A dehumidifier is not going to be that much more expensive than an ERV. And yet with a dehumidifier and a damper, you can both introduce ventilation and control humidity all year long. And you can control that humidity not only on the incoming air, but you can also dial in a home's indoor humidity throughout the year at any point, independent of the air conditioning cycling, which is, I mean, it's just a fantastic thing. If you've ever lived in a home where this is the system that's installed, it's absolutely incredible, because you don't depend on your heating and air system to dehumidify your air, which means that your system is going to run much more efficiently. And in the shoulder seasons, like today, where I am right now, I'm in Northwest Georgia right now, and it is not very hot outside, but it's almost like a swimming pool. So on a day like today, my air conditioner is not going to run very much, but with a dehumidifier installed, I don't need my air conditioner to run in order to keep my humidity under control. And then we add to that equation the ability to run your fresh air through the same system. Then you have just fantastic control over both systems. And then of course, the dehumidifier doesn't always have to run with its compressor on. We've built them so that they can run with their fan only, in order to bring in fresh air as needed without bringing on the dehumidifier if that's not necessary. So the gold standard, if you will, is going to be the balanced ventilation. So if the supply only ventilation is not your style, and you want to really dial it in, then you are going to go with this balanced system, right? So with this, you're in total control. You know every bit of cubic feet of air that's coming in, and you control every bit that's going out, assuming you have a tight house. And so, I mean, these systems are really just, I mean, they're just really cool. I do really like these, but they tend to be expensive. There's I've mentioned this before, but again, it's worth repeating. There's ERVs and HRVs. They're very similar. They both supply and exhaust air, and they both recover heat from the exhaust process. But an ERV is going to also recover humidity, which means that while the air is being exhausted from the home, it passes through a matrix, and inside that matrix, the air does not mix, but the humidity actually transfers through that material, because humidity always moves from high concentrations to low concentrations. So assuming that the air outside is a lower concentration of humidity, as the exhaust air leaves the home, it's going to pick up a good amount of the moisture that's in the incoming air, and it's just going to take it right back outside. And so you end up with a pretty good exchange, and they usually are about 70% efficient. So and you might think, well, that means that 30% of the outdoor air, it's 30% of the heat and humidity of the outdoor air is coming in through that. And that is correct. However, if you think about it, your space is going to be a certain amount of cubic feet. And so you're not, and that would be a problem for your equipment if you were to all of the sudden change out all 8,000 cubic feet of your room. Let's say you had a room that was 8,000 cubic feet. If you suddenly exchanged all of that air for outdoor air at a 70% efficiency, then yes, your system, your main heating and air system would have a big job on its hands, and it might not be able to keep up. But these things are continuously running, and they have much lower CFM than the 8,000 cubic feet that you have. So that process is it's kind of like a trickle process. So your heating and air system is going to have no problem keeping up with that. So here's a good diagram of kind of how these work. If you take fresh air from outside at 95 degrees and you bring it into the house, as it's going through this matrix here, it's not going to mix, but there's very tiny holes that kind of form a weave through this box here. And as the air from the home, which is 72 degrees, is going through the box at the same time as the outdoor air, it's actually, the outdoor air is losing its heat to that cooler air, which is picking up that heat and taking it right back outside. And then if you look at an HRV or an ERV, we add to that the relative humidity of the air, and we get an exchange both of the relative humidity and the actual temperature of the air. These are, I mean, it's really a neat process to watch. The bulk of the expense of the HRVs and ERVs is in this little matrix here, this square box in the middle. The good news is those are permanent parts. They do not need to be replaced. They don't wear out. And there are filters on both sides. You can see this blue mesh filter. That is a washable filter. And so, you know, we're going to keep those pretty clean. You know, that's the maintenance component of it, is that you need to just check to make sure that these filters are not too dirty. So balanced ventilation, some of the cool features on our system, just for installation sake, just there's some really neat stuff where the duct collars are easy to take on and take off, so you can attach your ductwork in basically in an easier environment. Makes the install a little easier. They come with really good straps, so you can hang them from the ceiling of your basement, or you can hang them from the rafters in your attic. And that definitely is going to reduce the vibrations. But I mean, if you've ever seen or heard one of these things run, they are so quiet. It's almost hard to tell if they're on or not. And then we don't need to use dampers because the motors, there's actually two motors, one that drives exhaust and one that drives intake. And the reason that we do that is because you may not have the same exact ducting situation. So you may need more speed on your exhaust motor or more on your intake motor, just to get a balanced CFM, and you can adjust those motors independently. And that independent control is actually right there on the box. So it's really, really cool. You can see right here the speed control on this side of the box. There's a really cool, with just a few buttons, there's a really cool way to kind of balance these things and like switch from one motor to the other. So it's actually really, really simple to do. you'll see as you do it that one motor will ramp up and one will slow down. All of the wiring is also right behind this front panel here. And there's lots of different ways to wire these things up. You can run them with a thermostat, you can run them with independent controllers, you can run them with that 8150 controller that I showed you earlier. So lots of different ways to wire those in. Pretty much if you can imagine it, we can accommodate it. I already mentioned the straps. I think that this makes it really easy to install. But then, of course, on the smallest one that we have, which is the 70 CFM, this unit is actually pretty tiny, and so we have this little mounting bracket. It's almost like hanging a big picture or something, but you can just mount that bracket on a wall, and it just basically hangs there, which is really neat. I think I already talked about the removable collars. I'm sorry, I get ahead of the slide presentation sometimes. But you know, one thing that you'll always hear from us is that installation is key, right? We can make excellent products, but if they're not installed properly, then you know they may not work the way they're supposed to, right? So one thing that we do put a lot of time into is thinking about how do we design these things so that the install is as simple as possible. And I think, in my opinion, these removable duct collars, they just, I mean, it seems like a simple thing, but they really do go a long way. Now, one thing I am going to make a little joke about here is that in the picture we showed duct tape, right? We know that that is not a good that is not going to be a good way to hold anything over any kind of long-term situation. So we want to make sure that I call that out. If you attach this guy, please use a little bit of duct mastic and a really good zip tie. And then when you attach your insulation and your vapor barrier over your insulation, again, please use a good duct tie, a zip tie. And if you want to tape over the zip tie, that's awesome. You're awesome for doing that. But the long-term holding onto that collar is going to happen with the zip tie. So just a shout out there for all of those sticklers for duct leakage. So I did mention before the core, this little matrix here, this little box, you see the guy holding it up. You're going to want to remove and clean those yearly, or maybe more often if it's necessary, but usually it's going to be something around a year. And then you can just wipe the inside of the unit down if there's a lot of buildup there. It's important to remember that in some climates there's actually going to be frost buildup on this thing, and then of course and it can also condensate. So there is a drain line, and we want to make sure that that drain line does not clog. It's not going to be a bunch of water usually, but it can be in certain situations. So we want to make sure that that drain line does not get clogged. You can see here our ERV and HRV portfolio. We have 3 sizes. I'm not sure why we're not showing the third size here on our ERVs, but we have the heat recovery ventilators. We have the 150 and the 250, the 6150 and the 6200. Those are actually Energy Star 3.0 rated. So those are a little bit higher in on the energy efficiency side. And then our ERVs, we actually have 3 sizes. We have the 70, we have the 150, and then we have a 200. Sorry about that omission there, but if you see the part number there, the VNT5, and then you can see 070 is the 70, 150 is the 150, and then if you just take that part number and you just put a 200 in there, then that would be the part number for the 200 CFM unit. We do have lots of ways to control these things. Again, we never just do things one way. the digital control, which is the true IAQ. This one is going to control, it's all it does is control IAQ systems. It can control fresh air, dehumidification, and humidification all at the same time. And it's a digital control. It's very nice. You see it down here in the bottom left-hand corner. We have a T6 that will control ventilation only. And that is the TH62 or 6320. So again, there's a mistake there in that. So apologize for that. But the 6320 WF 2003 is actually the only T6 that will run ventilation. And we do that because it's used in new construction a lot. And it will actually introduce internet weather data. And even though it won't display the weather data on the screen, it will use it to determine whether or not to lock out the ventilation. Then our Wi-Fi Vision Pro 8000 is going to do the same thing. And then of course our RedLink Vision Pro 8000 can do it. There's many ways that you can do it with RedLink. You can use wires, you can do a wireless outdoor sensor, or you can attach the RedLink 8000 to the internet through a gateway, and you can use the internet weather data to do it. And of course, my favorite of all of our thermostat systems is the Prestige IAQ. I love this system because it allows you to hit all three from one thermostat. So you can actually do dehumidification, humidification, and ventilation using one thermostat and an equipment interface module all at the same time. And if you attach it to the internet with the gateway, then you've got internet weather data. So you are set up to basically have the best indoor air quality control that is available. And then of course our T10 is a great option as well. And that one's going to be able to do one of the three types of control. So ventilation, humidification, or dehumidification. I'm sorry, I skipped ahead there. I just want to touch on this one more time. If you're looking for something that is easy to install and really easy to set up and commission, these ERVs and HRVs are really what you're looking for, because you really don't need a whole lot of extra stuff to do it. And if you wanted to just run them on a permanent constant mode where it's just always on, you can actually do that from the speed controller itself. So there's lots of flexibility here. Now, that's a lot of data that I just went through, and I understand that it might be a little bit much to remember. Of course, if you have questions, I invite you to start putting those in the chat window, and we will try to get to all of them. So go ahead and start typing those in. But one way that we have set up for our contractors to really dive into IAQ is our Residio Air Cycle program. If you have ever had trouble with talking to homeowners about their indoor air quality and then turning around and making a sale on that, I recommend that you take a look at this program. This is a fantastic program. Essentially what we did was we said, we need to stop guessing about what people need in their homes, and we need to give them good data-driven suggestions. And so that's exactly what we do. We actually will come in, we'll train your team, very in-depth and intense training for your entire team, from management all the way through your technicians and install. We will set up in collaboration with your company, we will set up an entire new IAQ system, an operation system essentially, where we will train everyone who needs to be trained on how to look at this in a new way, using data, using data from scanners that we actually that come with the program. And so your technicians and your sales team and whoever you decide you want to use these things will go into a home, they'll run a 30-minute scan, and they'll get actual high quality professional grade IAQ data capture, which then actually immediately downloads to their email and in a format that they can actually present directly to their homeowner right there on the spot. We have put tons of work into making this into something that is very user friendly, and it makes sense. And we have everything from the front end to the back end covered. So if you're interested in more, if you want to sell more IQ, if you want to grow that part of your business, and if you want to get better and more in-depth training on our IQ programs, then head over to residio.com/air cycle and check that out. You can also take a look at residio.com/pro, which is our newer website. It's been around for a little while, but it's if you've ever gone to forwardthinking.honeywell.com, this is actually the replacement for it. But you can head on over there, and this is a professional facing website, so it's all information that's geared towards you and your business, and it's going to give you the relevant information, what you need. So some of the common questions, and I see there are some questions in the chat, and I will take a look at those here in just a second. But before we jump into that, I do want to address just a couple common ones. So does the ERV need to be ducted into the HVAC system, or can it be independent? And the answer is yes, it can be both. You can duct it into the HVAC system. And that does work fantastic. But if your situation calls for it, you can also do it in an independent way. A really good way to do it, and you can actually do it in a hybrid way. You can introduce the incoming fresh air into your HVAC system, but exhaust the stale air from some other areas. So one way that people have done it in the past is maybe they will exhaust from their laundry room, or maybe from their one of their bathrooms, or two of their bathrooms, or maybe from their kitchen. So there's and of course a note on the kitchen is it doesn't, you don't want to pull that exhaust from the kitchen from like your stove exhaust. That would not be a good way to do that. But if you wanted to put a duct into say the ceiling of your system or kitchen or something like that, it's a good way to pull out some stale air. Or you can just do complete HVAC system integration. There's many ways that you can do it, and then you can control it in various ways as well. Is a bath fan sufficient for ventilation? According to ASHRAE 62.2, technically yes. Exhaust only ventilation can meet standards, but also you have to look at your local municipality, and I don't have enough room in my brain to hold all of those in my head, but every municipality, it seems, has different interpretations. So you gotta know what's going on locally for you. But technically, exhaust only ventilation is sufficient to meet some codes, but personally I would say that it is not. I would not recommend that as a strategy. And then how often do you need to clean the core of the HRV or ERV? I think I already answered that, but just to repeat it, and that would be yearly or as needed. So for the Q&A, I see that we have one question, and Jamie would like to answer that, I think.
Yeah, I just marked that for us. Good question coming in from one of our attendees. Can we use an ERV in the north during the winter to keep moisture inside the home? Winter can obviously be a little dry.
Well, yeah, I mean, that's a fantastic question. So the cool thing about an ERV is that, well, it uses physics, right? And I'm not a physicist, but I do know enough about physics to know that moisture is going to migrate from high concentration to low concentration. So if the air that's coming out of your home is higher in concentration, in humidity concentration, as it passes across that dry incoming air, it's actually going to put the moisture back into that incoming air, which is exactly opposite of what you might do in a hot, humid climate, right? So the moisture is actually going to migrate in the correct direction, if you will. Does that make sense? I hope that makes sense, because it's going to go from high concentration to low concentration. So in the summer, which was the examples that I used, because I'm from the South and we don't really care about humidity in the winter. But in the summer, you've got high humidity coming in, and as it passes across that low humidity air that's coming out of the house, it actually gives a lot of that humidity to that exhaust air, which is then pushed right back outside. But in the winter, when the situation is reversed, the ERV, simply because of physics and with no additional controls, will actually reverse that cycle. So the answer to your question is that yes, it can keep moisture inside the home. Of course, you got to remember that it is not 100% efficient. It does have an efficiency loss. So I see one here from Sergey. So if kitchen exhaust fan is over 400 CFM, we have to provide an additional air intake to match exhausted CFM. Do you have any product to heat this air if it's cold outside? So what you would be looking for there would be a duct heater. We do not have a duct heater. One way that we have actually accommodated this is for your customers specifically with 800 CFM. And here's just a side note, anything above 400 CFM is just absolutely excessive for a kitchen. But I understand that everybody has customers who want what they want. But if you got, I've seen homes down here in Atlanta, with these big 1400 CFM monster exhausts over their stoves. And, we have to address that. So if you want to bring 800 CFM of makeup air back into the kitchen when that thing's running, we can actually do that. We have a really good static pressure control, which is going to allow you to basically, you can hook that up to our exhaust, or you can hook that up to our intake damper. And when the static pressure within the duct from the kitchen exhaust goes out of whack, it'll actually open up that damper. And if you introduce that into the return plenum of your system, then you can actually reheat that air before it comes into the home, and you can kind of mitigate that. Now, if you don't want to do it that way, if you really wanted to heat the air right there in the intake duct, then you would want something like a duct heater. And they do exist, but they are not, that's not something that we make. So I hope that answers that one. And then the last one here that I see in the chat, and we're at time here, so I need to wrap up, but so setting up an ERV with communicating equipment when you have to use equipment temp controllers. What I would recommend in that situation is something like our True IAQ, which is one of our digital IAQ controllers. That will allow you to use an independent control to run your humidity. You can also do, if you didn't want a digital one, you could also use our 8150 controller, and that would independently control the ventilation system. And you can either integrate it into the blower of your equipment, or you can do a completely independent system. So that's what I would recommend for that. Just as I'm wrapping up here, I just want to remind everybody that we do have an online training portal. You would access that through your pro account. So if you go to residio.com/pro/resources, you can see all of our training options there. And then again, if you need to go back and see any of the recordings, we record all of our webinar series. You can go to residio.com/webinars, and you can pull up all of the recorded webinars that we've done. And then finally, if you do want to earn your 1 hour of NATE continuing education credits. You can do that by attending this session live. So if you did that and you want to get credit for that, please email holmes.university@residio.com. Include your first name, your last name, and your NATE ID. And you must do that within 1 week of today. And we will submit those credits on your behalf to NATE. If you submit that after 1 week from today, then that will not be processed. One last note on that, if you need more continuing education or NATE credits, reach out to your local rep. And if you don't know who that is, please type that in the chat or in the survey at the end. Your local reps can actually give live trainings on site, and we can provide continuing education and NATE credits during those live trainings on site. So thank you so much, everyone, for attending. We appreciate your time. Sorry, I went over by about 3 minutes, but I do
No
appreciate
worries.
your time.
Thanks so much, Chuck. And just to reiterate that, if you don't know who your Residio sales rep is, please go ahead and send an email to homes.university@residio.com, and we'll happily connect you with your Residio sales rep. And then just to quickly follow along with something Chuck just mentioned, you will be prompted to complete a survey once our training is completed today to give us a little bit of feedback on the training you sat through today on our ventilation portfolio. We're interested in not only your feedback on today's session, but also any future topics you'd like us to cover in the future, as well as you're going to receive an email in just a couple of days from us that includes some follow-up information on all of the products that Chuck reviewed with us today, as well as a link to the website with information on our future webinars as well. So thanks everyone for joining today's Residio webinar session. Have a great day, everyone.